So same is a concept called as queue. The key difference between the stack and queue is that in the stack we can only add and delete at one end only. Okay, so whatever comes, whatever goes last comes out first in the stack, and so you can call this as the last in first out, or it is also called as LIFO, last in first out. And in the queue, what is that? Here we have two ends. They are named as front and rear. Okay, they are named as front and rear. So we add at the rear end. Okay, and we remove item at the front end. So whoever is the front will be removed that. So whoever goes first, comes out first. So it is called as first in, first out kind of a data structure, FIFO. So if we draw it, it will be like this. So a stack is kind of this, in which you add an item, so that goes at this position. Then you add item at the top of this item. Then you add item at the top of this. Okay. So there is only one end in which you can go. So the end in which you can be inserted is this. This is a closed end. This is closed, while this is open. Okay. So now, so when it is to be removed, then you remove the one which has recently come is removed. So this is called a stack. Now, the queue is that in which you have this kind of data structure. So here, let's say this is an array first of all. Okay, array. Okay, then you add the element. So this is called as front and rear. Okay, initially front and rear at the same location, let's say it is. Okay, so you add an item. So item is, let's say this kind of item is added. The front remains here, then the rear goes here. Rear is moved ahead. Then a new item is added, and the new item is, let's say this is added. Okay, so this is added at the second position. Then let's say new item to be added, then rear moves ahead, then rear goes here, the new item is added. And if you have to delete anything, then it has to be deleted at this end, which is called as the front end. So while adding it, you add at the rear end, and while deleting it, you delete from the front end. So there are two ends in the queue. So you can typically represent like this. So this is so there are both ends. So this end is also open, and this end. Okay, so now if you want to add it, so the person gets added here, and if you want to add another person, then add it here. If you have to add, then add it, and if you want to serve it, then this will be served first. Okay, so this will go out first, then this will go out, and then this will go out. All right, so that means now let us see what will be the value of the front and the rear. Okay, so let us try to implement it instead of array. We'll try to implement it with the linked list. Okay, so if we have to do the implement the serving of it using linked list, then you can do it like this. Initially, you have the front pointer and the rear pointer. Let's say F is a front pointer, R is a rear pointer, and they are both initially pointing to null. That is nothing. So right now our queue is empty. Now a new node gets created, and let's say we put the value to it, some value called as let's take a problem statement, and we'll take that itself value. All right, so we'll read a problem statement. So the problem statement is queues are frequently used in computer programming, and a typical example is the creation of a job queue by an operating system. If the operating system does not use priorities, then the jobs are processed in the order they enter the system. Write C++ program for simulating job queue. Write functions to add job and delete job from queue. So we will assume that the jobs are processed based on first come first serve basis, right? That means the job which comes first will be served first, and the job which comes later will be served later, like that. Okay, so we'll have it as a job queue in the form of first come first serve. So let us take now this is a job, and let us take for this job we have a job ID and a job time. Let's take, okay, how much time is required to execute that job. So that will take two important information about a job. Let us implement now. So we will implement job scheduling using queues, right? Here we will use the Fcfs algorithm for job scheduling. So what is Fcfs? First come first serve. Okay, and let us use linked list data structure to represent the queues. All right, so now here we will have two information about jobs. The first information is that the job ID, and the second information is job time, how much time is required to execute that job. So now we will take the job ID as something called as X, or let's say we'll take it number, that's better instead of a character. So we'll take it a number. The job ID is, let's say, some 12, and the job time is, let's say, to execute it is required, let's say, 10 seconds. Right now this is the only job that is present. Okay, and let's say so nothing is present, so it points to nothing. So front is also here, so front is pointing to this, and rear is also pointing to this. Now we have to add one more job to it. Okay, so let's say a new job is to be added, and that job is with job ID 15, let's say, and job time is to be executed, let's say 5 seconds. So now this is the first job, this is the second job, so we must connect it. So let us have a connection from this job to this job, and this job is not pointing to anything, so it is removed. Now rear is this, so this is a rear. Front is here, and rear now moves ahead, so this rear is removed and rear goes ahead. Let us add one more job. So the new job is added with job ID, let's say 20, and job time is, let's say, 7 seconds. So now this must point to this job. Okay, so then we have a pointing to this, and rear now moves ahead. Okay, so rear is now pointing to this. Now this rear moves ahead. Now we have to process the job. We have to serve the job. So which job will be served first? So this job will be served first. All right, because it has entered first. So this has to be served first. So now what serve means that we will process it and delete it, because once it is served, then it has to be removed from the queue. Okay, job queue. So it has to go out. So now, so we will process it and we have to remove it. So that means we will remove this, and then the front will now point to this. So front will come to this. So now we remained only with two jobs. Now let's say now one more job to be added. So now a new job is added which must go after the rear. Let's say the job ID is, let's say, 25, and time required is, let's say, 10 seconds. So this must be now connected. All right, and then rear must move ahead. Okay, so rear will come here, and this one. So this is our job queue. All right. So this we have implemented. First come, first serve. Serve means that we have to process it and delete it. That is called serving of it. So now, if now serving has to be done, then this has to be deleted. And the front now points to this. Now again, if we have to process it, there is no new job to be added. So this has to be removed now. And front and rear both points to the same location. And now, so this has to be processed. Then this is now again removed, and then the front and rear becomes null. It becomes again null. It points to nothing. That means our job queue is empty. It is empty. All right. So now let us try to implement this using C++. Now let us take online editor. Let us create a new project. Let us take a language as C++. All right, so we got it. So same thing now. We are now very much comfortable with singly linked list. So same thing we will use it now. So we have a now class Q. Okay, so class Q. So in that class, what is we required? We require is the job ID. So int job ID. We require it int job time. Right, and we need a pointer. Q pointer next. So it will point to the next node in the job queue. All right. Now let us have a public function. Public. So in the public function, we will have to have what two operations we have to do? We have to add the job in a queue, that is called as add, and we have to have process the job, or you can call it as the delete the job. Okay, so we have to have these two operations to be implemented. Okay, so let us implement add the job with the help of constructor. So a constructor will be automatically called when we create the object of this kind. Whatever object of this kind we created, it will be called automatically. So we will ask to the user cout /n. Let us add job in a job queue. So cout enter job ID. We will ask to the user job ID, and we will read that scene job ID. Then we will ask to the user enter the job time. So cout is cout /n enter job time. So seen job time. Now, so we will have next. Right now it will point to nothing, so it is null. All right, because it's the last node and it is pointing to nothing, so it is null. Now we have to connect it to the front and the rear. So let us create the pointer called as front and rear. So we'll have the static pointer, so that we only require the single front and single rear pointer. Therefore, we can declare it as static pointer. Static q pointer front and pointer rear. Right. So these two pointers are required. So now, if front equal to null, then what does it mean? It means that it is a first job to be added in the queue. All right, it is the first job to be added in the queue. Now, if it is empty, then what we have to do? Very simple. You have learnt it how to do it. Okay, then we have front is equal to rear is equal to this. This means whichever has called this function is represented by this pointer. Now, else, that means it is not the first. It means that it is not first job. Okay, it is. So there are some jobs available. So, and the last job is the rear job. So we need to have rear ka next is equal to this. And rear is equal to this, because rear should move ahead, isn't it? So that means, for example, if we already have the two nodes, this node's already there, and we have to add one more node into this job queue, then it will be like this. Let's say the job ID is 5, time required is 5, and it is pointing to new job. Let's say the job ID is 10 and the time required is 7. So here front is here and rear is here right now. Now this new job to be added. So what we'll do, we'll have rear connects. So rear connects means it will point to this, and this object is this object, this pointer. So we have rear connects is equal to this, and we have rear equal to this. That means now rear will point to this. So rear is now pointing to this. Okay, so now it is successfully added, and now we will give the message cout /n the job ID. The job ID is in the job ID. Is successfully added in the job queue. All right, we'll highlight the message so that we can come to know now it has properly been added. Now, so we need to have one more function for process the job. Okay, so process the job means that we have to give the allocate the or we have to run this job and remove this job from the queue. Let us call this as process the job. Okay, so let us call the function process void process job. So what we do in the process job? So cout /n the job with job ID. Let us take the job ID is in the which we are processing. We are processing this job, and how to get the job ID? So it is pointed by front. So front ka job ID means the job ID of this node. All right. So the job with job ID, that means front ka job ID is successfully processed and will be removed from the job queue. All right, let's put that message. And then now what has to do first before deleting it? We have to make front point to this order. Or if we delete the front, then what will happen? That it will be lost. Then we will not be able to recover the address of this node. Okay. So before deleting the front must point to this node. All right. So how to get that? So let us take a temp pointer, any pointer, and we have to delete this also. So what we'll do, we'll take one pointer called as PTR, and we'll try to store its value, the front value into PTR, and then for front will point to this, and then we will do delete the PTR. Okay, so let us have a pointer Q pointer PTR is equal to front, and front is equal to front ka next. Now it is pointing to the next node, and then we'll have delete PTR, delete the pointer PTR, and then we'll have message cout /n, the job is successfully removed from the job queue. All right, so that is what we have done, process job. Now let us put our menu driven programs. All right, so we'll write a menu driven. So cout /n menu. So /n one dot is that add job in a queue, in the queue, /n two dot process the job and remove from the queue, and let's have /n three dot is the display the job queue. Let's have one more function. Okay, we have not written yet the moment. We will write down the display the job queue, and then finally let's say exit /n 4 dot exit, right? Cout /n enter your choice, and let's say in choice. We need the integer choice. All right. Now, so based on the choice, we will do these operations. So switch choice. So first is case one. Case one means add job in a queue. So let us call the object. So we'll have a pointer queue pointer obj, and we'll create a new object. Obj is equal to new queue. Our class name is QUE. Okay, new queue. Right? So now it calls the constructor, and then after that it automatically gets added. So we'll break that case. Okay, so it will not go to case 2 then. Now case 2 is the process the job and remove from the queue. So let us call that function. So you can call it with obj process job. All right, so and then break. There is one more case now, case 3, which is display the job queue. So we will we'll write the function later. Let us give the name to that function. So display job queue. Okay, let us this function and break. And case 4 is exit. And if no such a case is, any case is not matched, case 1, case 2, case 3, case 4, then it is called as default. Default case means any case which is not matched, either this one. Okay. So default case means if we have entered instead of 1, 2, 3, 4, we have entered let's say 7, then it will match with default. So we'll have message cout /n, please enter correct choice, because it has not entered correct choice. That's why it has got into default. Now let us write the function of display also. So void display job queue. So what we have to do? We have to go from front. We have to go from front till the rear and display all the jobs. Okay. So we need a pointer. So queue pointer ptr is equal to front, and while ptr not equal to null, we have to traverse. So we have to cout /n job ID and the time that we have to, or let's say print only job ID. Okay, so cout the job queue is, and we will print the IDs. It is in ptr job ID, and then followed by some spaces so that it will have space between the two job IDs. Now, done. Now let us execute this program. Now we have one thing is remaining in this. We have not initialized front and rear. Okay, so that we have to initialize it to null first. So you know how to initialize it. Static variables. So you have to go into like this. Q pointer Q front equal to null, and same thing rear equal to null. Now let us run it. So it has given the error. In the exit, some number has to be there. So let's say the 0 number. Okay, now it has successfully compiled. Let us now add job in the queue. Okay, so 1. So let us add job in the queue. Enter job ID. Let's say job ID 12. Job time is, let's say, 5 seconds. The job ID 12 is successfully added in the job queue. Now program finished with exit code 0. Let us see what is the error. New queue is added. Then we have break it. Break.
Sir, while loop.
Yes, while yes. We have to continue it till the user says yes, I have to continue. While 1. Very good. मैं हमेशा भूल जाता हूँ while लिखना. This now has to go inside. Okay, while this, and then while we have to terminate. Okay, good. So now एक condition ये भी रहेगी. Let's say user says process the job and remove from the queue, and maybe the condition that the queue is empty. So we will put that condition also. Process job if front is equal to null. If front equal to null, what does it mean? It means that the queue is empty. Cout /n the job queue is empty. is empty. Else all do this. Okay, so this we have to do in the else. All right, that's it is. Now let us run it again. Now if I put the process the job directly to, then it has to give a message that the job queue is empty. Right now there is no any job. Okay, now let us add the job. So let us add the 12. The time is, let's say, 5 seconds. The job ID 12 is successfully added in the job queue. Now let us put the again add the job. Let's say the job ID is 15 and time required is, let's say, 7. So the job ID 15 is successfully added in the job queue. Now we will display the job queue. Right. Control C. We have not given yes. PTR is equal to PTR next is not given. Display, yeah, PTR is used, but PTR is not moved ahead. PTR is equal to PTR ka next. All right, now is correct. Now let us run it. So if I try to display 3, so the job queue is now it is empty. Okay, so now add a job 12, 5. Let us one more job 15, 7. Now display the queue. So we have the job queue is 12, 15. All right. So we already have 2 jobs into a queue. Now we will process the job and remove from the queue. So let us 2. So the job with job ID 12 is successfully processed and will be removed from the job queue. The job is successfully removed from the job queue. Okay. Now let us display the job queue. So we see that only 15 is remaining. Now add one more job. So it has to be added after 15. Let us have the job ID as 20, time as 10 seconds. Display. So we have the job queue with 15 and 20. Now let us process. Now let us process. So 2 number. So it is the job ID 20 successfully processed. Let us process one more time. 2. It is saying the job queue is empty. Okay, because 20 is removed and nothing in the job. So now we are successful in implementing the job queue. So this is how you will implement the job queue. Okay. So do you have any question in this? It is same like we have implemented the singly linked list. So you can call this as we have implemented this queue, but only the thing is that we have changed the pointer name. So in that we had a pointer name start and end. Here we have the actual queue pointer that is called front and the rear. In the front, the job is deleted, and in the rear, the job is added. Any doubt?